Hello, this is the Blast Report podcast on all things blasting. My name is Evan Tebow with New Wave Consulting, and I want to thank all the drill and blast teams along with those supporting them who are out there on the pattern. The production team at Blast Think and I would like to welcome you to today's episode of the Blast Report podcast. Okay, welcome to another episode of the Blast Report. We've got Paul Sterk here again. He's going to be our co-host and going to be quizzing him on some nice questions of his history. And well, where we left off, we had spoken about misfires and his origin story at White Pine. And I think probably everyone kind of knows Paul for being the lead guy in charge of blasting over at the Homestake mine. So can you give us a little history on that and how you transitioned from White Pine to Homestake and some history there?
Yeah, back in 75, somewhere in there, 76. Actually, I transitioned from there to when I was at White Pine there, about halfway. I was there about 2.5 years before we went on a partial shutdown. And before I did, I went back to school. And the reason I wanted to do that was I was working for a guy who was superintendent of mining on my side of the mine, and he won his job by winning the 4th of July drilling contest at the 4th of July mining show. And
wait, I need some more detail on this.
Well, that's how
did that happen?
Whoever won the drilling contest was going to become the new superintendent. That's how they did it. And
the jackleg.
Yeah, jackleg.
So the best jacklegger would then no longer have to jackleg.
No, he was a miner then, you know. I mean, he was the boss. So
he wasn't the one in charge of jacklegging.
Yeah, and he was smart enough. He knew a lot about mining. Don't get me wrong, you know. Miners been doing all their life and they know a lot, but there's certain things on ground control and that they don't know. And I had a friend that his dad, he got slabbed at the mine, died. And I always said it was because, you know, the ground control problem, and this superintendent didn't know. Not, you know, when you're young, you're going to right the world, you know. So I'm going back to school to do that. So I went back to Michigan Technological University, MTU, or Michigan Tech, more people know it by. And when I went back to school, I was still working at the mine for about a year, and then the mine got a big donation to open up a student mine. So, and then they got a donation of all kinds of equipment from White Pine, but it had to be certified operators. And there was only 3 or 4 of us in the whole school that had worked at White Pine and were certified. So we got this equipment, and we actually started out this mine. And so I was going to school and working there. I was a shift boss, and it was a great experience because we actually built a student mine. We built classrooms underground and a compressor room and magazines, and built a water supply, you know, dammed up a creek and made water. And so it was a great experience. Learned how to build a tailings dam. And
it doesn't get any more hands-on than that in the classroom setting, huh?
No, it doesn't. It really doesn't. So it was fun.
I know Paul Wurzy and all the guys over at Missouri Science and Technology in Rolla. That's where I went to university. We had the experimental mine, and I know Colorado School of Mines also has an experimental mine. It's a little further from campus, but we went out there. And you know any other universities that have an experimental mine?
I think UK does.
Oh, absolutely. Okay, yeah,
UK does, and
New Mexico maybe, or
New Mexico might, and Arizona might. I'm not real sure. Neither one of those I ever visited. So
I definitely think that is a crucial opportunity for mining engineers to be able to actually get underground and get some hands-on with some product and different pieces of equipment. Did you how long did that process work when you were working at the university?
What do you mean the process of?
Yeah, like how long were you working with that equipment that White Pine donated and
About another, yeah, the whole time I was still going to school, and then I ran out of money and I left. The project still went on. In fact, my son Dan, who a lot of you know, he actually worked in that same student mine that I worked in at the time. Back when he went to school at Michigan Tech. So
That's
there was two
awesome.
of us. Yeah.
And he saw any old alma maters of his dad?
Yeah, well, there was
writing on the wall, right?
Yeah, well, I told him that there was a place by the shaft where there was a wall, and the number 6 shaft on 7 level that I'd wrote my name and the date on there. And anyway, they wandered back there one day. They were able to get in there, him and another guy, and sure enough, he found it. So he didn't believe me that I'd been in there, So I've been through all that mine. Because the mine now is filled up to, it started to drain at 7 level. It went outside. That's why we had to build the tailings dam for all the water. The mine filled up over years. I forgot, it's been 40 years since I was there, So things fill up, water does. If you don't turn the pumps on, you don't have pumps, it's going to fill up. So, but anyway, that winter, then they decided they were going to end that program for a while while I was working there. And so I headed west, like Horace Greenlee used to say, I think, it was head west, young man. And
yep.
So I loaded all my stuff up and headed west, and I was actually going to Wyoming, down by Bridger, by Rock Springs, where some of the mines are down there. There were some friends from White Pine that were living down there, so I was heading there. But I stopped on the way in the Black Hills in South Dakota to go skiing, because I had Park Service friends there from when I was a boat pilot. I knew a lot of people there. So, and at that time on unemployment, unlike today where you just get on the computer and type in, I went here and I went there, and they send you money in the mail. We had to get 2 applications filled out, copied, and mailed in, to get your money every week, And anyway, there was a mine in this town where I was going skiing called Homestake Mine. I went, oh, that's pretty neat. So I went to the office. I said, I need to get a job application for my unemployment. And they go, well, how would you like a job? And I said, I'm not really looking for a job. I said, I would just like an application. He goes, no, you go get a physical after you fill this out. So I went and got a physical, and the next day, or he said, then come back the next day. So I come back the next day, and they said, you report tonight. And I went to work.
Night shift.
Yeah, starting on the night shift. And,
that's a nice story, but I wish you would have had a little bit more of a ski season.
Yeah, that was pretty short after that. So.
I'm a big skier myself, so
yeah,
that's you're pretty close to being a ski bum, but now you ended up going where Homestake. Now, how big was the operation at Homestake when you joined it?
When I joined it, there was 1,800 miners there, 1,800 people.
And it was big. It was already the deepest mine in North America at that time?
At that time, yeah. So
8,000 feet, right?
Yeah.
8,000 feet below the surface. For some of our listeners who are, surface miners, I know some people who they would never in their right mind go underground. It's just not in their body, right?
Yeah.
For you to go down 8,000 feet,
there's an old
pretty
story.
Hot, right?
Yeah, the temperature in the mine varied from about 34 to 45 in the winter to 35 degrees in the very upper sections of the mine, and all the way down to 133 on the bottom. So, and there's a rule of thumb there for somebody that wonders, like, why are limestone mines always, they seem cool but not cold or hot, And the reason for that is you take the average mean temperature wherever you're at, where at the head frame or at the portal, and you can look that up on NOAA has that, where you inland like lead, it was I don't know, the average mean temperature was around 42 degrees for the whole year. So you take that and then you add 1 degree for every 100 feet you go underground, and you'll be within pretty close to what, give or take some, you'll be pretty close to what temperature is. Yeah.
Now those temperatures probably had quite a bit of an effect on the explosives products you were using down there, right?
Yeah. We did a lot of testing on new products for various explosive companies, because to see how they'd work in the cold and how they'd work in the warm, So. So we were like a beta mine for a lot of that stuff.
Yeah. Did you stay away from dynamite with those temperatures, or
We pretty much didn't.
a
Dynamite
lot of
was kind of
sweating?
when I started there, and what was it? It would have been 78 when I started Homestake, and dynamite was pretty well done in that mine at that point. We were running stick powder, and at that time it was water gels. That was before emulsions, so we were running water gels and anto. And as time goes on, you'll get a lot of. We were driving a new heading in the mine, exploration drift, and it was deep, 6,800, and it was hot, 100 degrees in the face sometimes, and the powder company guy said, we really need to bring dynamite in. We'll solve this problem. I go, you're going to have a bigger problem when you bring it in, because we don't have enough ventilation, one, and two, these guys would never handle it, and
they'll get their headaches.
They're going to wipe their forehead. They're going to touch their face. You're not going to have gloves on all the time.
Even worse, they're going to touch their balls.
Yeah. So anyway, as it turned out, that's exactly what happened. They weren't in there 3 days with that stuff. People were just screaming, because they weren't, even sometimes with gloves. But, it's very common to wipe your face when you're sweating,
Mm-hmm.
And they get the big powder headaches. So we were pretty much done with dynamite by that time. So, and we took it back out of the mine. We never used it.
Never use it again. Now, with the water gels, what was kind of the situation there that had a large temperature range, and was it a wet mine, or at those depths, or just kind of depended on where you were at?
Yeah, depending on where you were at. Most of the water was in the mine. We made ourselves, from drilling and wetting down the piles and stuff like that. You created a lot of that. We pumped about 1,500 gallons a minute out of the mine. So, because eventually, when the mine got finished, they did a water study on what was going on, and we had basically, where the mine was at, there's this giant sphere around the mine where all the water had been sucked out of the water tables and everything else. It was kind of like a thing, and they were kind of worried when the mine shut down and everything would go, and all the water would come in and deadwood would go underwater and all kinds of stuff, but wasn't quite that bad, and of course the mine's still open today, they're keeping the water level at 5,700, so that's mile deep.
And so, what's the story with that? There's a national laboratory down there, right?
Yep. Yeah.
Were you part of that at all before you left?
No, just a little bit. We were doing preliminary stuff, when they knew the mine was going to shut down. They were looking at projects, and people were coming in and doing experiments and stuff. It was kind of interesting, some of the stuff they planned on doing, and they're doing today with black matter and stuff like that. Because when we were there always was a lab at the mine. It was built in the 50s to catch neutrinos, but they also they were doing a lead decay, nuclear test decay study there, and then they had radio telescope that was set up all through the Black Hills and not many people knew about, that collected information at night and it all downloaded to the mine. And then we had a big bank of computers that went down this ramp. It was all automated, maybe 10, 15 computers. And every morning at like 7:30 or 8, they would turn on and download all the information to somewhere in Washington, D.C. We don't know where. Military people come in and stuff and spook people. But they paid their bills. They were in their own little section of the mine on the 4850, and nobody questioned it.
And there was no more production there. So
no, not they were way.
Kind of had their own area.
Yeah, and it was way away from production. So, and and I can remember one of the neatest experiments I had. This was just towards the end of the mine when we were talking about the mine shutting down. The Navy came in one day, and there was a sailor and a captain or something, and they had this box, and they said they wanted to go to 7400, and we took them to the 7400 shop. We had a big shop in the 7400, and he puts this box on the middle of the floor, and he rolls out cable about 20 feet to the left and another cable 20 feet to the right, and he turns it on, puts his headphones on like we have, and he goes, I got him, Skipper. Here you go. and he was talking to a submarine in the Indian Ocean with this little machine.
No way.
Yeah, they liked the fact that the ground where it was at, they could do so much in the ground at that depth. And it was a low wave thing. They explained a little bit to us, but. And then we were also, every underground mine they don't talk about a lot, like White Pine was too. We all had a seismic system set up for nuclear tests. So they were all across the United States and into Europe. And so when the Russians would drop a bomb, or the Chinese, they could tell by the size of it, by the seismic. They'd put all the seismic readings together, and they could tell. So we had one of those there forever,
Did you ever pick any up? Did you ever...
we used to pick up the blasts in the Powder River Basin sometimes when they'd have those big 5 million ton blasts and stuff.
Oh, yeah.
Yeah.
The golden days.
Yeah. That was back before the Russians made them quit doing that,
I did hear a few stories of people doing that, and the Russians kept blaming America on continued nuclear testing, and they're like, no.
It's another coal shot.
You should have just seen it fly this time. I also heard about a misfire where there was not a misfire, but a sympathetic detonation. It was overly sensitized cast blast, and it had jumped to the second shot that they were loading out in the Powder River Basin.
Yeah.
And so you had way more holes go off on an initial delay, and it was so much so that it definitely notified everybody who had a
seismic thing. It looked like an earthquake when it went off, So
any papers written about that one at Best in the West? No.
I don't think Himshaw or anybody really came to a conclusion of what happened there.
Yeah, no questions asked.
No questions asked on that. But
so
and it was kind of funny. I was also when I was at Homestake, we were having trouble with. There were some actual earthquakes going on, not big, like 2.0 or whatever, in the area. And I was underground in an earthquake one day, and that's really weird. I'll tell you, because everything goes, it all moves. You move, the walls move, everything just kind of moves, So it's quite an experience.
Do you see your utility lines all moving, or do you kind of feel
moves.
like you're part of it?
Yeah, everything, you're just part of it. You all move together, The ground goes up, you go up, it's weird.
I was in Bosnia not that long ago, just about 2 years ago, when they had a very large earthquake. It ended up hurting a lot of people in Albania, but where I was at in Bosnia, we were just in this really beautiful old building, really close to the flame that's still lit from the Olympics there in the 80s. But that was my first large earthquake where you could really feel everything shake at a very low frequency.
Yeah.
And it definitely gives you that appreciation when you're dealing with blast frequencies and how to maintain higher frequencies so you don't have that same type of damage and interaction with the structures. But I could only imagine what it's like being inside the earth down at that depth, knowing that you're in the belly of the beast when it's moving.
Yeah, it's interesting. It's always a good experience, as far as that goes.
Were there a few people who quit after that?
Oh, no.
No. Okay.
Hard rock miners, pretty tough people,
Pretty hard to scare.
Yeah, they've seen a lot. You've seen a lot, and you lived through a lot, and every now and then you would get people like that, that were scared of it, But very seldom. If a person knows pretty much as soon as they get off the cage if they're going to like this or not, when they get off on the level and they walk in there, they either like it or they don't. So.
Yeah, day one of orientation, they'll be out of there.
Yeah. And like you said, it's not for everybody, but it is for a lot of people as far as underground goes. But and you don't want people that are scared because that's going to affect safety for everybody. They can make an error or something like that.
Right.
It all goes back to that safety deal.
I tell people that, people that don't know mining or friends of mine, I tell them usually I'm in a very large tunnel, and sometimes with 150-foot backs. If it was in a benched room and pillar mine, let's say in the lead belt in Missouri, or underground salt or limestone, and but I've never been in underground coal, and I've never got to experience like a 4-foot seam or a 36-inch seam, something like that. I think that would be quite an experience to see, but I've never had that same level of intimidation from being underground. But I'm also a caver, so that kind of has a little different situation there. But how big, I think you've told me quite how large some of the stopes were at Homestake, and some of your blasting methods that you had there. You helped invent some of these methods, right? I mean, you can be humble about it, Paul, but
myself and my colleagues, in the blasters, the guys on the ground, they make it all happen,
Absolutely.
We did that. We did some long hole. We had stopes that were 300 foot high or higher, 450. And then big ore blocks, we tried to keep them, 150 feet, because you don't want to get too much opened up, because then it has a tendency to cave in before you backfill it, And,
So for our surface guys here who do a lot of the bench blasting and haven't really been underground, do you want to kind of go into detail on what that is, these long holes, and when you mean what do you mean by backfilling in the stope?
Well, to address the backfilling, we'll just say we have an ore block that's 500 feet long, it's 50 feet wide, and it's 150 foot deep. And we'll mine all that rock out, through a process of either vertical crater retreat or drive a slot on one end, or raise, which would be like a sinking cut. We would put a raise down one end, so we got something to blast to. And then we would just slab it all off until it's gone. Then we'd muck it all out. And then when you go to backfill, you fill that back in. And so it put some support in the walls and that. And then maybe run some sand in there too to help stabilize the ground. Because you don't want all these open things underground, especially because of the pressure, the deeper you go. You don't want to have an opening that's, 500 foot long and 150 foot high and 50 feet wide at, say, 7,000 feet underground. You don't want to keep that open any longer than you have to,
You'll see some spalling.
Yeah.
You'll hear it.
Yeah.
And so you would drill vertically as well?
Depending on how the ore block was. Otherwise, it would be angled holes. It could be vertical, it could be angled holes. It all depends on the ore block, which, geology defined out. They define exactly where we're going to go. So.
And you were telling me that there was times when when the ore was pretty low grade, and you'd have to drill 90 feet vertical because you didn't have a tunnel or a drift above.
Well, that's where we got into what we call blind hole raising, which is the Canadians did it and we did it, and what it was that you had all the big stopes or big areas of rock were gone, and it's not like a limestone quarry where like all your stuff is there as far as you can see. Like on the surface, there's your limestone pit. It's all there. Like ours are in pods. So you got waste rock in between. And we had these pods that weren't 150 feet high. So say it was 50 feet high. Well, you couldn't afford to go cut a topsill, drive a ramp up. You'd have to drive up to the 50-foot elevation and then go in there and cut a topsill big enough to drill vertical holes. Well, at $1,000 a foot for development, and all you're getting out of it is waste rock. You can't afford to do that. So what you do is you drive in a tunnel on the bottom through the ore body and to one end, and then you put a blind raise up, which has, and by blind raise we mean there's no top. So it's like a sinking cut turned upside down for surface guys. And then you shoot that, and then you blast everything into it. And then to backfill, it's a little bit harder, of course, because you don't have a topsill. So we would backfill those with sand. You drill a hole from up above and take mill sand and put it in there. So, and cement sometimes.
Wow. And so what's the diameter of these boreholes?
The ones we drilled about 2.25.
2.25, and how deep? 90 feet up?
80 was about
80 feet up at 2.25.
Yeah.
How did you measure deviation at that point? Or
Yeah, we did. We were having a lot of trouble when we first started out with, deviation going all over the place. What we did to start out with was we hired an actual driller from one of the drilling companies from Bort, actually from a drilling company. We hired him for a year to come in and train all of our drillers. And we've got into specialized bits and steel, guide steel and guide bits, and got into all that. And after their training that, they could drill a 70-foot hole, 75-foot hole, and you could see the back of the hole. I mean, that's how straight they were. And if they did vary at all, they all varied the same if the geology did it. It made it. So, but that was back before, old pit blast, and everybody had these
probes and
for probes and that this was back in the day. We were before that. So, but we still use some of the stuff like they do today. For big holes down, we just used a flashlight.
Right,
put it on the rope and drop it down. If it disappears, you know which direction it went. Going there. And a lot of time we would, if there was a top and a bottom, you could put put string down with a number on it, and then survey the top, survey the bottom, tie it all together. So,
yeah, there's definitely different ways. You got different technology out there, but there's always the old mirror and flashlight trick, definitely.
Yeah, and then but then now you got Vortrac. There's no reason not to
have.
There's no reason to have that equipment. It's come down in price so far from the old days.
Absolutely,
there's no reason not to be doing it.
It's so user friendly as well.
And and it's underground. It's not as critical for fly rock as it is on the surface, because where's it going to go? So.
Now, as you were doing these blind hole raises and things like that, you would you published a lot of these papers and would present these in different SME and different communities.
Yeah.
Did you ever were people adopting these same practices in other nations, and how was the global effect that Homestake's research had on the mining methods of other places? Did anyone ever vocalize that with you?
No, nobody ever has. Whether we had any effect on that, I think the only global thing that I know for sure had an effect was when we developed. We were a cyanide mine, and they developed a bug that ate cyanide, and it was a technology that they came up with. They found some life on the 8,000 level. These bugs were alive in the water that had cyanide in them, and they cultured them so they could go till they were 99% cyanide, and then they'd die. So all the water was filtered through this on the surface. All the water that came out of the mine was filtered through this, and this technology then they sold worldwide. They gave the patent to the South Dakota School of Mines, and they sold it worldwide. So a lot of places there's cyanide mitigation going on in that. It's with this process. It's from this process. Yeah.
Wow. So they found these microbes at the 8,000 level.
Yep. And then grew them, in the lab. So
this is the first I've ever heard of this.
Yeah. Like super, super hybrid.
That is unbelievable. So, and that technology that biology, let's say, those microbes are still being utilized to this day.
Yeah.
Wow, that's a really unique.
Yeah. So, and it was a pretty cool system they had up to there too, because fish are very sensitive to cyanide, and just like people don't realize that there's probably more cyanide in a lima bean than there is mining. Lima beans are full of cyanide, man. It's terrible, but neither here nor there. But they had a fish pond there, a special pond they built, and all the water after it went through this filtration process, and the cyanide got eaten off by the bugs and that, and the water that was left, they ran through the fish thing. And if the fish died, they knew something was wrong. So right away they would shut off. They had a big plug they'd just pull, and all the water would start going back in the mine. They'd do it over again. Wow. So we used fish to make sure that the water was clean that came out and went down the hill.
Yeah, I mean, fish float, right? That was a pretty big indicator. Yeah. Well, I'm going to have to look into that some more and hear more about that. That's unbelievable. Well, thank you very much, Paul. I appreciate you coming on, talking a little bit about the Homestake mine and some of the technology that's come out of there. I mean, it's definitely has a reputation. When I joined the industry, you know, people always talked about the Homestake mine and things like that. So it's nice to hear some knowledge of firsthand history lesson.
So, well, thank you for having me on tonight, and be looking forward to being on some more down the road. So
absolutely. All right. Well, you have a good night.
Okay, you too.
Take care.
Be safe.
Thank you for listening to this episode of the Blast Report podcast. I want to thank the team at Blast Think for producing this show, and please follow along for more episodes in the future, and share this podcast with your colleagues so we can continue to honor our industry and the people in it. Be safe and have a blast.